Hello everyone, I am Maheshwari. I am currently pursuing my MBA in Sri Venkateshwara College of Engineering affiliated to VTU, approved by AICTE, recognized by UGC under section 2F and 12B. Today's the subject is Operation Research, and this operating research subject sir has assigned me the topic of linear programming problem. First, let me see the introduction of linear programming problem. Linear programming problem is a mathematical technique used for optimization where the goals is to maximize or minimize a linear objective functions subject to set of linear constraints. It widely applied in various fields such as economic, business, engineering and military applications. And when we are coming into this key component of linear programming, the first one is objective function. This is the function that needs to be maximized or minimized. It is expressed in terms of decision variable. For example, if x1 and x2 are decision variable, an objective function could be z equals to c1 x1 plus c2 x2, where c1 and c2 are coefficient representing the contribution of each variables. And then second key component is decision variables. These are the variables that decision makers will decide the values of in order to achieve the best outcome. They represent a quantitative that could be or that can be controlled or adjusted. And then third component is constraints. These are the restrictions or limitations on the decision variable. They can represent resources, availability, capacity, limits or any other restrictions relevant to the problem. Constraints are typically expressed in the form of linear inequalities or equations. For example, a1 x1 plus b1 x2 lesser than or equal to d1, where a1, b1 and d1 are constraints. And then fourth key component is feasible region. This is the set of all possible points that satisfy the constraints. It is typically represent graphically in 2 or 3 dimensions where the feasible region is area that meets all constraints. And last key component is optimal solution. This is the point in the visible region that yields the best value, maximum or minimum for the objective function. And the next step is steps in solving a linear programming problems. The first step is formulate the problem. It means define the objective function, decision variable and constraint clearly. And then second one, graphical method. For 2 variable problems, plot the constraint on a graph, identify the feasible region and find the corner points. Evaluate the objective function at each corner points to find the optimal solution. And then step 3 is simplex method. For problem with more than 2 variables, the simplex algorithm is commonly used. It systematically explains the virtual of the visible region to find the optimal solution. And then fourth step is sensitivity analysis. Once the optimal solution is found, analyze how changes in coefficients of the objective function or constraint affect the solutions. And then applications of linear programming problem. Resource allocation. Optimizing the use of limited resources in production process, transportation and logistics, minimizing costs associated with transporting goods. Diet problems. Finding the least cost diet that meets nutritional requirements. Finance, portfolio optimization to maximize returns or maximize profit or minimize risk. And last part of this video is conclusion. A linear programming is a powerful tool for decision making and resource allocation or resource or optimization by structuring a problems in terms of linear relationships. It allows for effective, efficient solution to complex scenario across various industries. Understanding its components and methodology is crucial for effective application in real-world solutions or situations. These are all relevant to this linear programming problem. If you are having any doubts or any queries, please do comment on my YouTube channel in this video. Thank you for watching this video till end.